Greetings, everybody. Today we're going to be presenting on differentiation rules for the class Math of Physics. Our teacher is Mama Evelyn. This is by me and my classmates Jordan Tejeda, Nia Rush, Noah Alcantara, which is yours truly, Io Dele, Dudiyemi, Sela Bruno, and the school we go to is Aya Educational Institute. This is how we formatted our slides. We are going to be talking about what is the rule, how is it used to find a derivative of an x, how does it work, what are the steps used in the different rules, what is our catchy phrase, and using our catchy phrase and the rule in an example we created. Now I'm going to be passing it on to my classmate, Brother Jordan.
Constant rule number 1. Next slide, please. Constant number 1 means that any number that's by itself is 0. So in this equation, 5f of x equals negative x squared plus 8x minus 11. What you would do is you would take the derivative of negative x to the second power plus 8x minus 11. And then what you would do is you would take once you get the derivative of negative x squared, you get negative 2x. When you do the derivative of 8x, you get 8. And then for the derivative of negative 11, since every number is 0, which is my catchy phrase, that would be 0. Next slide, please. Constant rule number 2. Constant rule number 2 means that if the variable has a number in front of it, then you take the derivative and multiply by the number. So in this equation, y equals 5x squared minus 49x plus 12. How you do this is 5 prime of x equals 5 times derivative of x squared minus derivative of 49x plus derivative of 12. And then you would get 5 times 2x minus 49 times 1 plus 0, since your 12 every number is 0, so you have 0 for that. And then 49, the x is just a 1, so you just have 49 here. And then for 5 times 2x, catchy phrase for that is take the milk and eggs and you get French toast. So you'll take the 5, which is the eggs, and then you take the milk, which is 2x, and you'll get 10x minus 49. And now that's your French toast. Next slide. And I'll be passing it on to, I think it's Io Dele.
The power rule is when you put the exponent in front of the number, and then you take the exponent and subtract it by 1, and then multiply all of that by the derivative of the number. And my catchy phrase is E goes in front of N, so there is 1 less E on top of N times N when you're older. And so my example is fx equals x to the 4th. And so what you do is f prime of x would be 4x to the 3rd, because you took the 4, which is the exponent, and put it in front of the x, and then you subtracted 1 from 4, so that's 3, times the derivative of x, and then the derivative of x is 1. So if you do 4x to the 3rd times 1, then you get 4x to the 3rd. And I will be passing it on to Noah.
Thank you very much. I'll be talking about the product rule. The product rule is a formula used to find a derivative of products of 2 or more functions. The catchy phrase for the product rule is d over dx. Base times base equals prime times base plus base times prime. So for my example, is f of x equals x to the 2nd power times 8x. So getting to the simplified f of x prime, we will do x to this second power times 8 because we simplified the 8, so it became a prime, plus 8x times 2x. We simplified the x to the second power to 2x using the constant rule tool. And then we move down, we times the 2x by 8, and we get 8x to the second power plus 16x to the second power because we times both the 8x and the 2x. And then to simplify it even more, we would get 24x to the second power, and that's how you do the product rule. Next, I'll be talking about the quotient rule. The quotient rule is used to finding the derivative, also known as the slope of x, at one point. Specifically, in helping to simplify the equation when there are two separate functions in the numerator and denominator to help find a derivative of a given equation. The catchphrase I want to use is, I'm going to explain it in Easy Zulu. It makes it easier for me to understand. It helps you learn a little bit of Easy Zulu. So it's a win-win for both of us. So what I'll be using is Niga, which is Easy Zulu for give, and that will be representing the numerator, and La, which means food in Easy Zulu, representing the denominator. My catchphrase, simplified, is if f of x equals Nika over Dla, then f prime of x equals Dla times Nika prime minus Nika times Dla prime over Dla to the second power. So take your time leisurely to translate that. And so I will be explaining my problem. So f of x equals 2 times 2x to the third power plus 4 over x to the fifth power. So our numerator, which is Nika, equals 2x to the third power plus 4, and our Dla, which is food, equals x to the fifth power. So using the quotient rule, x to the fifth power is our Dla, so our dx times d over d, the derivative of 2x to the third power plus 4 minus 2x to the third power plus 4 times the derivative of x to the fifth power over x to the fifth power squared. And so if we simplify that more, it will become x to the fifth power times the derivative, or the derivative of 2x to the third power plus 4, which is 6x to the second power, minus 2x to the third power plus 4 times the derivative of x to the fifth power, which is 5x to the fourth power, and then over x's 10th power since we times it by 2. Now I'll be passing it over to my classmate and sister, Selah.
All right, I'm going to be explaining the extended power rule. So basically, for the extended power rule, it's just the power rule but fancier. A way of remembering the extended power rule is putting the exponent in front of the equation times the derivative times the equation again. My example is x to the fifth power plus 2x cubed. F prime of x would be 3 times the expression x to the fifth power plus 2x cubed minus 1, since you're using the subtraction of the exponents from the power rule, times the derivative of the expression written again, x to the fifth power plus 2x cubed. Simplified more, this would be f prime of x equals 3 times x to the fifth power plus 2x squared times the derivative of x to the fifth power plus 2 times the derivative of x cubed. We write this to divide up the problem to find out each of their derivatives. The final part of this expression would be f prime of x equals 3 times x to the fifth power plus 2x squared times 5x to the fourth power, because we put the exponent from x to the fifth power down and subtracted 5 minus 1, which is 4, plus 6x squared, because we put the 3 down and multiplied 3 times 2 to get 6, and 3 minus 1 is 2. Next, I will be talking about the sum difference rule. So for the sum difference rule, a way to remember this is the first equation times the derivative of the second equation using addition or subtraction to plus or minus the second equation times the derivative of the first. You can do this separately. An example of this is 4x to the sixth power minus 8. The way to find this is f prime of x equals the derivative of the expression, again, 4x to the sixth power minus 8, which is the derivative of 4x to the sixth power minus the derivative of 8. F prime of x of this is 4 times the derivative of x to the sixth, since we're dividing this problem, minus the derivative of 8. Next, this would be 4 times 6x to the fifth power, because we put the exponent 6 down, and 6 minus 1 is 5, minus 0, 0 representing 8 because it is a singular number without a variable, and every number without a variable is a constant. This final expression would be simplified to 24x to the fifth power, because 4 times 6 is 24.
So now I'll be presenting the complicated problem. For the complicated problem, we have f of x equals, open parentheses, x plus 3, close parentheses, to the fourth power, open parentheses, 7 minus x, close parentheses, to the fifth power. And what we'll do to start that problem, this problem, is the product rule, which is primes times base plus base times prime. And as you see right here, this is how we have it. So the derivative of 7 minus x to the fifth power times x, times x plus 3, then we'll have plus 7 minus x to the fifth power times derivative of x plus 3. Next, we're going to use the extended power rule, which is the power rule but fancier. And then as you see on both sides, we did 5. We took down the 5, and we did 5 minus 1, and we got 4. And then we also took derivative on the insides, which is the sum difference rule, and which you can do separate. And then we also did it on the other side too, where we did with the 4. When on the 4, you did 4 minus 1, and you get 3. You also took the derivative of x plus 3, and we'll go down, and we're going to go down to the next line, which is 5 over parentheses 7 minus x to the fourth power. 0 minus 1 is the derivative of 7 minus x, and then you have x plus 3 to the fourth power plus 7 minus x to the fifth power, and then you have times 4 open parentheses x plus 3 to the third power, and then you have 1 plus 0, which is the derivative of x plus 3, and then your answer is down below right here. 4 open parentheses 7 minus x to the fifth power, open parentheses x plus 3 to the third power minus 5 open parentheses 7 minus x to the fourth power, close parentheses to the fourth power, open parentheses x plus 3 to the close parentheses to the fourth power, and then the simplified version is down here. And thank you.
Appreciate y'all for listening.